Hello guys, this is going to be the first video in the LiDAR data video series. We'll probably be doing update videos as the process evolves a little bit, becomes more refined. Had a lot of interest in people wanting to know how we're getting the LiDAR data, how we're working with it, how we're getting it into 3S Max, and that's what I'm going to cover in this video. So the first thing we're going to do is we're going to download a program called Cloud Compare. So I'm just going to Google Cloud Compare, and the top result that comes up is, looks like Daniel or Danielle gm.net/cc Cloud Compare. Highly recommend donating. Not affiliated with this person at all. Don't know them, don't know anything about them. This program is absolutely fantastic. Highly recommend making a donation using their link. But it's absolutely a wonderful program. So you want to download it, hit the download button, and download whichever one works for you. I see that he's actually got a new one versus what we have, but again, absolutely highly recommend donating, because this is an absolutely wonderful program. It is free. It's not a trial version or anything like that as far as at the time of making this video. For what we're doing for racetracks and stuff like that, is absolutely the perfect program to work with LiDAR data. So again, the website is Daniel or Danielle gm.net/cc. Just type in Cloud Compare in Google and it should be the first result that pops up. Again, highly recommend it. There might be other programs out there that you can use, but this one absolutely serves the purpose, and it's what we'll use in this tutorial. So I'll go ahead and close that. I've already got that downloaded. Give me just a second here. Alright, so the next website we're going to go to obtain the LiDAR data is the Usgs website, TNM download version 1.0. You can just type in this address up here at the top, viewer.nationalmap.gov/basic/hashtag startup, or #startup, depending on what generation you come from. So that'll bring you to this screen here. So if we're working on a racetrack, I'm going to go ahead and open Google Earth here. You don't have to use Google Earth Pro, you can use whatever version you want, but just for example, if you don't know how to locate the racetrack on a map, I guess this is the first step here. So if you don't recognize where it is, just being able to zoom in. I've done this so much that I know pretty well where most of them are, most of the NASCAR tracks are. If I zoom in a little bit, you can see Sonoma Raceway, Infineon Raceway. There's turn 11 right there. This is a top-down view, obviously, and I've got places and borders and labels turned on. Looks like they've got the turns labeled on the road, but there's that. So what I'll usually do is I'll make sure I'm with north pointing up, and I'll kind of zoom out and I'll turn some of that stuff back on just so I can get roads and kind of make it match as far as what I'm looking at on here. So obviously we know it's over here somewhere. I'll start switching back and forth. There's Vallejo. There's Vallejo right there, so we know we're in the right area. It's this big lake here that we're looking at here. I'm not trying to, drag this out or anything, but just once you know the process, you may not find it as quickly. The level of detail We're not going to be working with Infineon today. We'll probably work with Pocono or something like that, and I'll show you why. But I just want to go over the process of finding the racetrack, and then we'll do the same thing a little more quickly to find Pocono or something else. Actually, you know what I'll do? I'll do my local track, Kilcare Raceway, because this is a good comparison between the resolution of this versus the resolution of Kilcare. Not every LiDAR scan is the same. What you're going to see here is insanely detailed. I mean, it's probably better than what iRacing has from a ground scan, and this is from space. This is, when you look at it in Cloud Compare, it is photorealistic, colors, everything, and I won't drag out too much here because it's easier just to show you, but I can tell you right now that not every LiDAR scan that is available on this website is of that magnitude. But it's nice when it is. It's also kind of a downside, and I'll go over that later, but it's almost too much data. It's just way more than you need for a video game. But, you know, it's nice to, it's pretty to look at, but, you know, we'll go over some of that here in a little bit. So there's Sears Point Road, which I assume is this road here. They're calling it El Camino. El Camino Real, not sure. It's also called 37. Yeah, there's 37 right there. So we know we're in the right area here. We got Cougar Mountain Drive. Is that the road that goes up around? There's Cougar Mountain Drive over there. So I'm assuming it's basically the road that goes. Okay, so we're looking at 121, 37, Lakeville Road. So we're looking at this little area right here. The racetrack is in this area right here, I believe. Let's see, yes. So this is the big mountain that they're showing right here. If you've never read topography maps or anything before, these lines represent height above sea level. So 600, 500, 400, anytime you see hundreds of feet very close together, that's usually a mountain, for lack of a better explanation there. And you can see there's clearly either a crater or a mountain, so it's probably a mountain. I can tell you right now, based on experience, that I am a little bit too zoomed in. I want to be on this level here. Seems to be the norm on most of these processes, is the stuff that we're using is extremely buggy, does not work all the time as expected. So I'm kind of hoping that actually happens here, just so I can show the different ways of obtaining the information on the same website. It's possible you may, I bookmarked this page right here. It's possible you may have to close the browser and start over again if it's not giving you what you expect. So I'll go over some of the settings here. You've got use map, current extent, which is what you see here, is what it's going to search for. You've also got box point, which allows you to draw an area that you want to obtain information from. Sometimes that works better. Sometimes current extent works better. Sometimes there's no rhyme or reason why one works better than the other. You'll go back and you need to get another piece or something. It may work completely different. So understand that there's tools up here, and you're going to have to fight this process. It's not super easy to use. So those are the only two that I've really used, and I've noticed that it returns better results if you're not as zoomed in. When you zoom in too much, it may not give you what you want. So I'll zoom out a little bit. Obviously, we really only need that area, but it may have a hard time searching because I'll show you here in a little bit. There may be a box right here, but it says, well, you don't have enough of that selected, so I'm not going to give you that result. But it may have part of the racetrack on it. So you want to make sure that you zoom out far enough. You can tell by the scale of the boxes, and I'll get into that in just a second. I'm probably dragging this out too far, so I'm going to go ahead and move on, and then we'll discuss that a little bit. Over here on the left-hand side in this area, you're going to tell it what product you want to search for. Now, product means LiDAR. What kind of map do you want it to return? What kind of data set do you want it to return? In our world, that's kind of foreign language that doesn't excuse me, it doesn't really mean anything to us, but you kind of have to learn what language they're using. So we're going to look for LiDAR IFSAR. If I'm saying that stuff wrong, apologize. I don't do this stuff. So I'm going to select that box there under elevation source data 3DEP LiDAR. That's the one we want. I want the LiDAR point cloud LPC file format LAS LAZ, and that's all I want returned when I search. So we're going to try this once. This may or may not work. I think earlier when I tried this, it took forever and basically told me no results returned. It is currently searching. It doesn't look like it's doing anything right this second, but it is. There we go. So we actually got a return there. It took a while for that to download. That's using the current extent. Now what I'm going to do is I'm going to hit start over, return to search. This time I'm going to do it with the box selection. And I think when I was practicing there earlier, it was a little bit faster to do that. So again, I'm doing LiDAR IFSAR, LiDAR point cloud LPC, LAS, LAZ, file format. Find product. Yeah, you can see the results are a little more refined by the number of pages there. What is listed in this page is way more than we could ever even dream of opening. I don't care what kind of computer you have. Your computer cannot handle opening all of these. Absolutely not. So what we've got to do is... I'm going to turn that off. We can do current extent. There we go. We've already got the results here. This part of using the website is a little bit buggy as well. So we've got different point clouds, and some of the stuff you need to be able to read over here is the date listed. So that's a 2004. That's a 2004. A lot of these are 2004. This one's a 2013. As with most things technological related, the newer it is, usually the better and higher resolution it is. A lot of the older ones, I don't want to date the video too much, but the current Charlotte road course, the first complete start to finish using LiDAR data that we're doing at SDS is, we're doing it on live streams, figuring out how to use this stuff and trying to get that information before we make a step-by-step how-to video. And I know I'm rambling a lot. This is not going to be as concise as a start-to-finish video. I just want to make sure that I cover every single error that you're going to run into. And it's not magic. It's just I want you to understand it's not super easy. You have to kind of muddle through it a little bit. So I want you to understand that. So this is a 2013. You can hit thumbnail and I'll show you where those are. You can see in comparison to our zoom level that these are relatively small in comparison to the view. That's obviously a very large area on the ground, but you can start turning these on and off. Again, our racetrack is right in this area. I'll download one of these just to show you the resolution. Basically, I'm just going to go down the list. I'm going to hit thumbnail until I find one that's part of the racetrack. And if you don't know exactly where your racetrack is, you're going to end up having to download all of these and open them all in Cloud Compare, which takes a lot of memory. Once you start turning these on and off really fast, you'll start getting ghosting, and it'll start acting weird and not doing everything exactly like you want it to. So I'll hit that, and that box might stay there. At that point, the website and or your browser is running out of memory. Basically is what's happening there. Understand, I have 32 gigabytes of RAM. So this is very hardware intense. So you can turn on the outline if that's easier. The footprint is just the outline box. We might just do this one here. If I remember correctly, LAZ is a lower resolution, LAS is full resolution. For what we're going to do, and I'm going to download this live. This will probably take a while. Actually, this won't take that long. It's only 86 megabytes. This one's not horrible. In fact, I might be on the wrong set of data here. I'll let this download and then we'll open it up in Cloud Compare. But Cloud Compare itself, wonderful program, does everything that we need it to do. It's also a beta, and the version that you download might be a little bit different. Even since we've been doing this, the beta has already been updated. So it is an actively developed program. They may be changing things in there. You might get a different result than what I have here, but at this point, I think I've gone over that. So I downloaded the LAS, which is the higher resolution. Go ahead and minimize this. Minimize this here. I'm going to open Cloud Compare. I'm also going to, off screen here, you can't see it, but I'm just extracting all of the files that I just downloaded. There we go, 180 megabytes. That's better. So this might be the right one. So what you got here in the file that you download from that website, you have the LAS data, which is the big file. You can see by the file size, 185,000 kilobytes. A lot of this is, the text and the XML are different versions to be opened in different programs. The LAS is the one that Cloud Compare is going to open. Some of it is definition data for these. I don't know how that file format works exactly, but you have to have that in the same folder, I think, for this to open correctly. So Cloud Compare is open. This is the working window here. This is kind of the file structure, and then the properties. The bottom window, you can close it. I'm going to wait till it gets open here and then I'll close it. Really not necessary for anything that we're doing. Alright, so on the desktop, it is under the Usgs LPC Sonoma. Now, in the website here, so if we do this and say this, because the racetrack takes up more than one section, I need to cover this at this point here. So let me backtrack just a little bit. I would turn on all of the thumbnails that cover the racetrack, and at this point, make sure you have a little bit of data around the racetrack too. Make sure you're not leaving part of the racetrack out. Download the LAS file for each one of those point cloud sets that cover the racetrack. Extract them all into one folder. So you would have, I think there's 11 to 15 different pieces for Sonoma. You'd have basically that many files. Really, the only thing that's important is the LAS files. But you would have 11 to 15, however many it takes to cover the racetrack on those squares. Put those all in one folder. That way when you have, the LAS files, and you can sort by type, and it would put them all together. Using Windows, you can shift select all the LAS files. I'm just showing you because I don't have them all in here, but just multi-select. So if you have to use Control to click each one of them and add it to your selection, let go of Control. Do it that way, but open all of the LAS files at one time with it selected in this screen here, and then hit open. So let me make myself clear there. Make sure you're opening all of the LAS files that cover your racetrack. So make sure you've downloaded all of those squares as LAS files, unzip them all, put them all into one folder, whether you rename it or however your workflow wants to be. Make sure you have all of those selected in that open dialog right here. Make sure you have all of those LAS files selected. Then hit open, and it will open all of those into one scene basically. So I'm going to go ahead and hit open. I've only got one in here just for comparison. I think in the interest of keeping things short and brief here, I'm probably just going to use this here and go ahead and export it. It will not be the entire racetrack, obviously. So you'll hit open, you'll get this dialog here. I have not changed any of the settings, so look over the settings here. This was default. I'm just going to hit apply all. Shifting this stuff, I honestly don't know how any of this stuff works. There is a scaling issue that we have not worked out. I'll go over that in 3ds Max briefly. I'm not going to show the scaling and all that 100% in this video. So at this point I'm just going to leave it all. Hit yes to all. You may get multiple dialogues there if you're opening multiple point clouds. You can see that's 5.85 million points. You can see this looks like a satellite image, and it doesn't match the color obviously, but if we go back to 2013, it's pretty similar in color. So it's in this area is where our this particular box was taken, this particular scan. This is one of the better scans. So if I grab it with the left mouse button, I'm just holding the left mouse button and moving the mouse. This interface is a little bit awkward. You can zoom in, you can see, water tower tanks over here. You can see just how much information is in here and how amazing that would be to build a road course off of, to have all that information. 5.5 million points or 5.5 million vertices will never work in a video game for the foreseeable future. Again, this is just one section, small section of the racetrack. This isn't even the whole thing. You have to be able to work with this information and get it reduced down to something a video game can handle, whether it be a 15-year-old video game like NASCAR 2003, 15-plus-year-old video game like NASCAR 2003, or a modern video game that may not even be out yet. A set of course of Project Cars, whatever. But you can see just by looking at this how valuable that information is right there. I mean, that is an insane amount of detail and information. Have not figured out how to get this you know, the coloration and all that kind of stuff to translate to a 3ds Max model. One thing that we need to do is I'm going to hit the, is it this one? Which one? This one here. So different buttons here will give you different views. I just wanted to get back to the top-down view. Also, to recenter, I'm just right-clicking and holding and moving the mouse. That'll pick the object up and move the camera around it. Or rather, pan the camera around the object, I guess is a better way of saying that. The model isn't moving. The camera is, obviously. Excuse me. This is way too much information to put into 3ds Max, so we need to reduce this to something that is basically the road only. So I think for this we're going to focus on just this little loop section right here. So I need to cut out, basically, or crop out information I don't need. So there's two things I need to do. I need to remove the outside of that area and the inside of that area, so that I'm left with basically only the road. Now for making objects, making filler objects, stuff like that, you can go ahead and make those into different objects and import that. But this is basically just to show you some of what you need to do here. At this point, I'm going to go ahead and close that bottom window, give me a little bit more viewable area. I need to have the entire work area on the screen when I click the tool, because I can't pan and move the camera around after I open the tool. So I'm going to hit the little scissors icon up here at the top, which is, if you mouse over, it gives you tool descriptions. Segment. So I'm going to segment that out. At this point, I'm going to hit the lasso tool, which is this one here. And at this point, it will give me, so I'm going to left click and it starts drawing a line. It's very similar to the lasso tool in Photoshop, if you're familiar with that. You can do this in multiple passes if you prefer to zoom in a little bit more to get more accuracy. You want to be careful of not removing too much or not removing enough, because they're equally as bad. Too much data. I'm just going to go ahead and square that area off right there. Again, this is just for demonstration purposes. I think I am just going to, in this video, just show this one section here. I'm going to right click to end drawing. Doesn't matter what shape that is. If there's nothing there, it's not going to be part of the process. So you can select whether you want the inside or outside. I honestly never remember which one this is, so I'll just go ahead and hit this button here. So that removed the outside piece, which is fine. What I'm going to do is I'm going to hit confirm selection. Now it looks like nothing changed, except there's a yellow bounding box around the piece that I cut out. So now, if you notice up here on the left side, there's two pieces, so I can turn off which section I want to work with or keep or whatever. Works exactly like you expect. So this top one is the outside data that I no longer need, so I'm going to go ahead and hit delete on the keyboard to delete that. So what I'm left is this piece here. I want to go ahead and cut out the inside of that, so again I'm going to hit, with the selected, I'm going to hit the scissors icon, make sure I'm zoomed in as much as I need to be here to be able to see what I'm doing. You really want to take your time, make those edges as clean as possible. It helps with identifying what you're looking at. One other thing I'll talk about quickly before I get too far and convert this into a editable polygon shape. Down here in this section, you've got different settings. Now the scalar field, you may not end up with a photorealistic model. Point cloud is what you're looking at. Yours may end up looking more like this. So I'm under scalar fields. It may end up looking like this. May end up looking like that. Just random weird colors. You really can't make anything out. Don't be afraid to change. Intensity is usually what you're going to be working with. So you can see that asphalt has a higher intensity than dirt and grass. So you can make out a lot of shapes and stuff by doing it that way. It's not as pretty as some of the other settings, but you can go through and get different results. So I'm going to leave it on intensity since that's probably what you're going to be looking at. Colors will be RGB. RGB might not be available. Basically is what that is. That's something that I just figured out as I'm doing this, is under that setting. So you may look and see if RGB is available. It may not be on every scan. You may end up having scalar field as the only thing available. But if you have RGB, then it's going to be the photorealistic Google Earth type image that you're looking for or looking at. So I'm going to go ahead and leave it on that. It's a little bit easier to see. So I'm going to just grab that and make that a little bit smaller. That's pretty good right there. So, alright, with that selected up here, hit the scissors icon, Polygon select. There's different tools there, rectangular selection and polygonal selection. So again, I'm going to left click, start the cutting. And you want to be a little more precise than what I'm doing here. I'm just trying to quickly get through this. It's going to end up pretty jagged here, and I don't want to cut too much of the road off and not have the information there. Doing an oval racetrack, what can happen is you'll end up with the concrete wall, the grandstand. I think we ran into that with a little bit of the Charlotte road course. One end of the racetrack was a little bit misshapen because I think we had too much data in there. So I'm just going to hit right click to cancel there, or in the selection process. So this time I want to do segment out and hit the green check mark. Once again, it removed that into two objects. Doesn't look like it did anything, but if I select one or the other. Okay, so looks like this is the one I want to get rid of. So again, with it selected, hitting delete. Now I have that segmented out. The other thing that I'll talk about right there, there is no undo, and I actually just did something wrong, but I'm going to go ahead and continue with this process just to show you what I did wrong here. You don't want to remove the inside before you convert it to a poly object, because it will insert polygons into the inside. I'm going to go ahead and show that and continue the process. There are some benefits, there are some negatives. It can alter it just slightly, so just to show, this has still got the height data. If we actually look at one side, you can actually see how much height data is there. So it may look flat from the top down, but it's not flat. I mean, that is an amazing amount of information right there. So at this point, we're we're basically done with it. Again, I would highly recommend not removing the inside until you do this next step, so I'm going to go ahead and show you. If you have multiple pieces in your scene, what you would do is same thing as in Windows. You would have a header folder with a file listed underneath of it. You would have that for each piece or each original square scan that you have. After you've cut all that stuff out, or maybe you want to do it before, depends on the workflow, you might want to do that first thing is go through and select all of the clouds, not the folders, the clouds. So you can multiple select there. Make sure you just clicking on that. So you'd hit Control and hold Control, and then select each one of those in that list. It's not highlighted, but you would do merge multiple clouds. Then you would do all your cutting and cut out your racetrack that way. That is worth mentioning. You probably want to do that first. But we're only dealing with one piece here, so I'm just going to leave it like this. So at this point, I've got it selected. I'm going to hit Tools, and give me a second to find it here. Okay, so under Edit Mesh, I think that word's Delaney. Apologize if I'm mispronouncing that. I'm going to hit the first option there, which is 2.5D XY plane. And I'm going to go ahead and leave that at default 0.000. Now you can see what I was talking about is it filled in all the open gaps as best as it could with very large mismapped polygons. You can also see in this list we have the point cloud data is still there, but it's been converted, so the verts have been removed. I want to make sure I'm selecting only the mesh, the output mesh there. Let me make this bigger so you can see it's dot mesh at the end of it. It's also got that shape there with the star in it. I'm a car guy, so that looks like an old Chrysler logo, but I know there's a term for it. This is what we want to export, so I'm going to save this as a .object, and I'm just going to go ahead and use that right there. So save that. That is spitting out 424,000 polygons. So that is just for one small section of racetrack. Now, keep in mind that is also the polygons that we're not going to use, but that is definitely not. We'll go through and clean that up just a tiny bit just to show you that process. So let me minimize all this here. Actually, I'm going to have to close some of this because of recording, and it just eats up too much memory. So I'm going to close all this before I open 3ds Max. If you do not have a very stout computer system, do not attempt to stream this. It's not going to happen. So give it a few minutes here. I'll close that. Make this viewport just a little bit bigger. So I'm going to go, oops, sorry. I want to import the object, which is this one here. I do not change any of this stuff. Again, we do have a scaling issue that we have not dug into, and it may be part of these settings that I have not dug into yet, or we have not dug into, I should say. As of right this second, we're leaving it all as is and just importing. You can see 424,000 polys, and actually it looks like it messed up a little bit. So I'm going to select that right there. The pivot is way off screen, so what I'm going to do is affect pivot only, center to object, in which case you can see that there's something going on here. Probably has to do with the mesh being created in there, so I'm going to go ahead and convert to poly. Select. You can see how much this thing starts chugging with this much stuff on the screen. I'm going to go ahead and delete that right there. That little piece sticking out. I don't know what that was from. But this is problems you may run into doing this, so I'm going to leave it alone. Effect pivot only, center to object. There we go. That's a lot better. Now if we go to move, you can see that these are way off. So what I want to do is go ahead and right click to center that in the scene and hit Z to zoom back to it. So now I'm in the center of the world. This is in the center of the world. If you've got multiple pieces, you really want to combine those in Cloud Compare, because doing it in here would be next to impossible to line it up with as chuggy as this stuff is. I'll show you my hardware monitor. It's not doing it so much because I'm not really working in here, but when I start working, this thing just shoots up to 100%. Memory shoots up to 3/4. That's with 32 gigabytes of RAM. Right there, 32,723 megabytes. So it gets difficult, and a lot of it is because I'm streaming. I'm using the same computer to stream or record than as I am to work. If I had a second computer here, obviously that would be a little bit easier, but so I've got the pivot in the center of the world. A couple things I need to do immediately is turn on orthographic view. For the next step, I'm going to leave that exactly where it is. Next thing I need to do is rotate that piece 90 degrees. I'm going to turn on angle snap. I'm going to go ahead and rotate that this direction 90 degrees. I'm going to go ahead and turn the grid off. Is this correct here? It looks like it is. So this is coming up. I don't know the corner numbers for Infineon. I don't race there very much, so forgive me, but this is coming up that little sharp corner right here. This is the old Sears point and field part right here. So what I'm going to do is I'm going to go ahead and show you how many polygons are inside of that. You can see how long that took right there from me clicking, how long that took for it to actually perform the task. So I'm going to hold control to multi-select. The other tool that might come in handy is the paint select. Kind of just do this, but you can see how much that lags behind what I'm doing. It's just from the time I hit the mouse button, it's actually jumping over a bunch of those before it even... Hopefully the video doesn't decide to crap out here just from the lagginess of this. You can see I got too far into it there, so you can hold Alt and deselect, but it'd be easier just to start over. So I'm just kind of holding control and left clicking, and it's right there. I'm going to stop right there, and then I'm going to get some of those over here. Get some of these here. Just to give us an idea, how many polygons is that right there? How many polygons did it add from Cloud Compare by filling that in? That was only 504 polygons that it added, under 1,000 total. Obviously I don't have them all selected, but so you can see the density of that mesh. I'm going to go ahead and delete those right there. The more you delete, the better the system's going to operate. Very, very quickly, I'm going to touch on a couple of things in the viewport. You can see when you have this selected, you get a lot of anomalies from doing that. Some of that is curbing, some of that is trees, bushes, signs, walls. You'll get a lot of information that looks like spikes. What you got to remember is what we're looking at is a compiled mesh. What the cloud is looking at are the vertices. I'm going to zoom out here and wait for the computer to catch up to what I just did. Yeah, it's not going to let me do this while I'm recording the video. It's just too much information. Yeah, it's probably going to crash. So, unfortunately, I'm going to have to end the video there. But you can kind of see how much information is here. Why I've been hesitant to even make the video, because it's just so much information. It is stupid how much information is in that. This is one section of the racetrack. This isn't even the whole racetrack. So yeah, it is. This part of it is the worst part to deal with, and it's why we haven't done a complete process video, because this is almost unusable on some of the meshes. I don't know if it's... Nah, it's completely locked up. Alright. Well, I'm going to have to end the video there, just because there's no way I can record this and do it at the same time. Let's see. I'll come back. Oh, it isn't locked up, but it will not let me select the information. The other tip that I was trying to go over, I'll do that real quick, is under Views. And it is under Viewport Configuration. Display selected with edge faces. Turn that off. That will help you visually see with it selected. What I was trying to point out was what we're looking at is a very lumpy, bumpy surface. You would not, even if the video game could handle 50 million vertices in a track geometry scenario, this would not be usable. You'd be driving over a cheese grater, basically. I can't show you in the editing window because the computer just can't handle drawing that many. But what you got to remember is the lumpy bumpiness that you're looking at is an interpolated set of data. What in reality is the vertices are what I can't select it, but you can see here the vertices are what the information is stored in, not the polygons in between. So that polygon is useless. That polygon means absolutely nothing. That is not the data that we needed out of this. The average of these vertices is what we needed. We're hoping to be able to get the actual LiDAR data into Sandbox or into a newer version of Max that can import that LAS data, which, you know, there are newer versions of 3ds Max if you have that. I don't know what that process is. I have Max 14. I don't know if Max 17 or 18 or 19 has the ability to import that LAS data into Max where it doesn't struggle so hard to use that information. If you have that available, definitely go that direction. But I can't help you with that because I don't have that version of Max. Like I said, more than likely this stuff is, you know, curbing or it's hard to say, but yeah, I can't do anything in Max while I'm recording this. One thing I kind of want to show here is the height data that is available. You know, it doesn't look like much until you start, you know, putting a flat plane in there, and then you can really see how valuable that information is. As of recording this video, the process is to take a spline based approach similar to R factor 1, R factor 2, laying out splines using cross section multiplier, which we'll cover in another video. It's been covered on a couple streams already briefly, but once we get that refined a little bit, basically snap the points of the spline to this mesh right here. Obviously the complete mesh, but basically build a spline track, cross section it, bring those cross section points up, and make it an average of this data, which I think is still far more valuable than guessing, what's the banking height. Well, I don't know, it's a road course. I have no idea. You can say, well, this turnover here is X amount of degrees of banking. Okay, well, does that tell you that that corner is that much lower than that corner over here? Or no, it doesn't tell you that. It's always been a guess. Well, I've watched videos of this and that. I know that you go downhill from this entire section. Okay, well, how much? How much do you go downhill? Now we have that exact information. Look at the numbers down here as I'm moving this. How much I'm moving that plane from down here. I know I can't see what I'm pointing to with my hand because there's no way for you to see that. But watch down here. How much does this number change from where it's intersecting right here to when it starts intersecting here, which is the highest point in this case? That's 122 meters. So in feet, multiply that by basically 3. That has, up until this point of having this information and this process, that has been a guess. That's the only way you could do it before this. So knowing that that's 122 meters lower than it is over here, which is why SBP, SDS has never done Watkins Glen and Infineon Raceway, because we didn't have this information available, and we felt that if there was no way to do anything other than guessing, then we just weren't going to do it. And now we have that information. That doesn't mean that's what our projects are going to be in the upcoming future, but it's one of the things that it's on the radar of, okay, now we have the ability to do that, as well as any other road courses. So hopefully that helps you out. Like I said, this process applies to anything. Think about Laguna Seca. Think about the iconic corner at Laguna Seca. You can now get that same information. What is the height difference between the top of that corner on the hill versus the bottom corner on that hill? That's one of the corners that I think of. Yeah, there are versions of Laguna Seca, but they are, well, I just know you take a sharp left-hand corner, a sharp right-hand corner, and you're going downhill. Well, I don't know how much that is. It's just whatever. Well, now we know. Now we can obtain that information. Now we can get it right. So, at this point, I'm rambling. I just wanted to show the process up to this point. One of the other things I'll quickly mention at this point is, and I should have said that before I was talking about the height difference. It's not 122 meters. And the reason is because this is very, what's the word, misscaled or not scaled correctly. This needs to be scaled using a satellite image. You need to have a satellite image top-down view on a flat plane. So I would have taken that flat plane, mapped the satellite image. I've gone over it in other videos using other planes to size up, use your measuring tools, however you want to do it. Size up the satellite image on a flat plane. Make this match. And again, if we figure out what the settings are in Cloud Compare or in Max to import it the correct size, we'll redo the video. And this is a lot of rambling, incoherent. We plan on doing other more concise videos in the future. So if I've lost you, there's no point in me saying this, but check back. We'll try to get this cleaned up a little bit. But I wanted to share the information that we have right now. If you are watching this and see a more concise way to do something, or you know of a better way to do something, feel free to leave a comment. This isn't a top-down, me telling you. If you guys see something that we're doing that's maybe not the most efficient way, absolutely speak up. This is a community. Help us build this process. I would absolutely love feedback on it. But basically, you need to rescale this and make sure it's sized appropriately on the X and Y axis. Scale it uniformly, and the Z axis will get scaled correctly as well. You can take that opportunity to line this up as well by rotation and all that kind of stuff. You would do that with the entire collection of segments or scans. Do that all as one. You're not going to record that process with a mesh this dense. It's not going to happen unless you've got, you know, another recording PC to do it. Alright, so I'm going to end the video there. I think that's all the information that I can provide up to this point. So I'll end the video there. Thanks for watching.